Hello and welcome to Build Succeeded. It's about time we get into some 3D stuff on this channel. And the first project is about implementing a 3D software renderer. This project will spread across multiple videos since it's so complex, and in this first video we will talk about perspective and projection. And to demonstrate that, at the end of the video we will have a wireframe cube rotating around. Let's get started. A 3D software renderer is a way to render 3D graphics on a 2D screen using no hardware acceleration. This was used a lot in early consoles, and I remember even later games like Quake 2 and Counter-Strike 1.5 having a software mode, aside from OpenGL and Direct3D. And software mode looked the worst out of the three options, but it was a good option for gamers without a graphics card. Nowadays, it is hardly used in any commercial game, since graphic cards are insanely powerful compared with what software rendering can do. But I believe building such a thing can help us a lot to understand how 3D graphics works. For this project, I will still use Direct2D, but only as a canvas to draw on. I will use no 3D acceleration, and hopefully, by the end of the project, I'll only use a method that draws individual pixels on the screen. So how do we display a 3D world on a 2D screen? There are different ways to explain this, but I like to compare it to the human eye looking through the screen as if it's a window into a virtual 3D world behind it. And this virtual 3D world needs to be projected on the screen. So let's consider this to be a top view of you and the monitor. This is your eye and this is the screen. This is the part of the 3D world you can see through the screen, and the center of the screen. Let's call the distance from the eye to the screen Z0. And let's consider this point right here. If the center of the screen is 0, 0, 0 in 3D space, we can say this distance is X, this distance is Z. There is also Y, but since we're looking from top down here, we can't represent it right now. We'll get to it later. If we draw a line from this point to the eye of the player, we can see it intersects the screen right here. And we'll call this distance x1. So it looks like we need to calculate x1 based on the other coordinates. Using basic geometry, since this is a 90-degree angle, we know that x1 over x is equal to z0 over this entire line, which is z0 plus z. So we can extract x1 to be x multiplied by z0 over z0 plus z. And that is it. Based on the same formula, we can also calculate y1. So now we know x1 and y1 of the projected point on the screen. And of course, since z represents the distance from the screen, z1 will always be 0, but that is not useful, so I'll set it to the old z. That will be useful later. But in these formulas, the only thing we don't know right now is z0, the distance between the eyes and the screen. To calculate it, I will use something called field of view, which is this angle right here. That is more or less fixed in 3D games, but even if it's not, we can calculate z0 easily based on it, using this geometry formula. Resolution divided by 2, divided by the tangent of half of the field of view angle. I'm not going to start from an empty project. Since I have the base code for my 2D games, I might as well use it. What it currently does is nothing. It initializes Direct2D and runs an empty game loop. If I run the application, you'll see an empty screen at 9000 frames per second. This is not the scope of the video, but let me quickly show you a few classes in the project. We have the app class, which mostly deals with creating a window and handling Windows events. Then the engine base, which is running the game main loop and has a few other basic useful methods. The GameObjectBase class is a base class for objects we want to create in the game. I use it to easily add objects into the game engine. And finally the engine class, which implements the engine base, and this is where we add our own logic. If you want to know more about this base part, check out my 2D game engine video. I explain it a bit more in detail there. I took the liberty to add a structure called point3d, which represents a 3D points coordinates in space, along with a method to create one. Now let's get to it. Let's start with setting the field of view angle, and we can do that in the settings.h header. This file is where we have settings for our games, and I'm going to define field of view to be 45 degrees. We can change it later if there are issues. Next, let's add z0 and some helping methods to the engine base class, and let's implement them. We're calculating z0 in the constructor based on the formula described earlier. Now we can implement a method to get it, since it will probably be used in other classes as well. I've added a translate method which can take a 3D point and return another 3D point that was translated using the translation variable. This is very simple. I've also added a rotate method, and this gets a bit more complicated. This is using what is called a rotation matrix. You can see all the geometry behind it at this Wikipedia page, and I don't pretend to fully understand it, but I can use it as a black box to obtain a point3d variable rotated with a certain angle on each axis. The rotation angles are stored in the rotation variable. Next is apply perspective. This is the method that calculates the projected point on the screen, based on its 3D coordinates. It's using the formulas we calculated earlier on paper. And then, since the resolution starts at 00 in the top left of the screen, and in our calculations 00 is the center of the screen, I've added this center screen method that only moves x and y by half the resolution of the screen. Let's demonstrate this method visually by creating, of course, a cube. Let's create a cube class. It will implement the GameObjectBase class and its logic and draw methods. We store the 8 corners of the cube as points in an array, and a white Direct2D brush to draw with it. In the constructor of the cube class, I'll set the position to be 400 pixels behind the screen, the initial rotation to 0, and I'll initialize the 8 corners of the cube. In the logic method, I'll simply change the rotation angle around the y-axis. To make sure we'll have a smooth rotation regardless of the FPS, we will use the elapsed time variable, which is the time passed between 2 frames in seconds. Now let's implement the draw method. First, let's make sure we have the brush initialized. I'll create another array of point3d variables to store the transformed points. Then I will rotate all the points according to the cube rotation. Then I will translate them according to the cube position. Then I apply the perspective and center them on the screen. After all this transformation, I'll draw the 12 edges of the cube as lines, using the transformed points. Finally, to view the cube, I'll have to add it to the engine, so in the engine class, we'll have to initialize a cube object and add it to the rendering pipeline. Let's run the application, and we can see the wireframe cube rotating around, and it's still working at 6000 FPS. Of course it does, we didn't do that much. Just wait until we apply textures, that will be an FPS killer. Let's move the cube further away. Instead of 400 pixels, let's move it by 4000 pixels. As you can see, the perspective calculations make the cube smaller. Let's bring it back and play a bit with some other variables. Let's update the field of view to be only 10 degrees. That would be equivalent with your eyes being really far from the monitor. What about if we set it to be real wide, like 120 degrees? That would be equivalent to sitting very close to the monitor. The perspective looks pretty weird in this case. Now let me update all 3 rotation angles of the cube and see what happens. So this is the first part of the 3D engine project. Make sure to check the second part where we are going to play around with triangles and display a solid cube. Check the GitHub repository in the description if you want to look at the code. Give me a thumbs up if you like it, and make sure to subscribe to see the next episodes of this 3D engine when they are released. Thank you for watching. See you soon!